Now, this is the tutorial on generative AI, and this deals with the types of generative AI. Generative AI encompasses various models and techniques that aim to generate new data or content that resembles human-created data. There are several types of generative AI models, each with its own unique approach to generating content. Some of the most prominent types of generative AI models include GAN, that is Generative Adversarial Network. It consists of two neural networks, the generator and the discriminator, that compete against each other in a game-like setup. The generator generates synthetic data, for example, images, text, sound from random noise, while the discriminator task is to distinguish between real and fake data. The generator aims to create increasingly realistic data to deceive the discriminator, while the discriminator improves its ability to differentiate real from generated data. Through this competition, GANs are capable of generating highly realistic content that they have been successfully used in image synthesis, art creation, and video generation. Second is variational autoencoders. Now, VAEs are generative models that learn to encode data into a latent space, then decode it back to reconstruct the original data. They learn probabilistic representation of the input data, allowing them to generate new samples from the learned distribution. VAEs are commonly used in image generation tasks and have also been applied to text and audio generation. The next is autoregressive models. Autoregressive models generate data one element at a time, conditioning the generation of each element on previously generated elements. These models predict the probability distribution of the next element given the context of the previous elements, and then sample from that distribution to generate new data. Popular examples of autoregressive models include language models like GPT, Generative Pre-trained Transformer, which can generate coherent and contextually appropriate text. Recurrent neural network is the next one, where RNNs are a type of neural network that processes sequential data such as natural language sentences, sequences, or time series data. They can be used for generative tasks by predicting the next element in this sequence given the previous elements. However, RNNs are limited in generating long sequences due to vanishing gradient problem. More advanced variants of RNNs such as long short-term memory (LSTM) and gated recurrent unit, that is GRU, have been developed to address this limitation. Transfer model based models. Transformers like the GPT series have gained significant popularity in natural language processing and generative tasks. They use attention mechanism to model the relationship between different elements in a sequence effectively. Transformers are parallelized or parallelizable, can handle long sequences, making them well suited for generating coherent and contextually relevant text. Reinforcement learning or generative tasks. Reinforcement learning can also be applied to generative tasks. In this setup, an agent learns to generate data by interacting with an environment and receiving rewards or feedback based on the quality of the generated samples. This approach has been used in areas like text generation, where reinforcement learning helps fine-tune generated text based on user feedback. Gartner, the technology research firm, said in their Emerging Technologies 2022 report, mentioning GenAI as one of the most impactful and rapidly evolving technologies that is going to revolutionize the working and impacting productivity. Prompt engineering is playing pivotal role in unleashing the power of prompts together with GenAI. With this one one can get an answer to the text, image, audio, video or other forms as you expected. This is known as generative AI models and the type of it growing rapidly. So it is understandable as to how vital it is to adapt generative AI to remain competitive in your business domain. Generative artificial intelligence models are a combination of various AI algorithms used to represent and process content. These models utilize natural language processing techniques to generate text, transforming new characters such as letters, punctuation, and words into sentences. Parts of speech, entities, and actions which are then represented as vectors using multiple encoding techniques. Images are also transformed into various visual elements, also expressed as vectors. Many types of generative AI models available, and the number continues to grow as AI experts experiment with existing models. With the classification of AI models below, it is possible for a model to fit into multiple categories. For example, the latest updates to ChatGPT and GPT-4 make it a transformer-based model, a large language model, and a multimodal model. GANs or Generative Adversarial Network, best for image duplication and synthetic data generation. Transformer-based models, best for text generation and current code completion. Common subsets of transformer-based models include generative pre-trained transformer, that is GPT, and bidirectional encoder representation from transformer, that is BERT. Diffusion models, best for image generation and video image synthesis. Variational Autoencoders, VAEs, best for image, audio and video content creation, especially when synthetic data needs to be photorealistic, designed with an encoder-decoder infrastructure. Unimodal models, models that are set up to access only one data input format. Most generative AI models today are unimodal. Multimodal models, designed to accept multiple types of inputs and prompts when generating outputs. For example, GPT-4 can accept both text and images as inputs. Large language models, the most popular and well-known types of generative AI model right now. Large language models, LLMs, are designed to generate and complete written content at a scale. Neural radiance fields, that is NERF, emerging neural network technology that can be used to generate 3D imagery based on 2D image inputs. Thank you.